In this lesson, you will learn how to classify a number as natural, whole, integers, rational, irrational, and real. So the first classification is what a natural number is. So a natural number is considered any number that can be used to count with. So any number where its value is a value that you can use to count with. So a little helpful way to help me remember this, when I look at the word natural, this L right here, I focus on how that looks like a 1. The L looks like a 1. Because when you ask a little kid to count, you go ask a little kid, hey, count to 10, they're going to say 1, 2, 3, 4, etc. So when a kid starts counting, they start at 1. You go ask a 5-year-old, they're not going to say, oh, -5, -4, -3, -2. They don't use the negatives when you ask them to count, let's say, to 10 or something. So that is how I remember that natural is all the numbers that are counting numbers, starting with 1. Okay. Then the next term is a whole number. And a whole number are the natural numbers, so all those counting numbers, but it includes one extra number, and that is 0. So 0, 1, 2, 3, 4, 5, etc. So a helpful way to remember this is when I look at the word whole, it has an O. It looks like a 0. So that's how I remember the difference between these two, that this starts at 1 and this starts at 0. So any number that can be turned into one of these numbers is considered whole. It has a whole number form. Okay, our next term is integers. So integers are all the whole numbers, so all of these numbers, and its opposite, so the negatives. So it would be incorrect to say that an integer is any positive or negative number, because it's not. It's whole numbers and their opposites. So whole numbers aren't decimals, so their opposites would be like -1, -2, -3. So not 2.5, not 3.6, or anything like that. So it's all the numbers that, if you think of a number line, you have 0 in the middle, and then 1, 2, 3, and then the opposites. So no decimals, no fractions. So for example, -3, -2, -1, 0, 1, 2, etc. Any number that can be changed into one of these is considered an integer. Okay, then we have rational numbers. And a rational number, the formal way to explain it is it's numbers that can be written as the quotient. So remember, quotient involves division, and we can use a fraction bar for division, of two integers. So that's a fancy way of saying something that can be written as a fraction. And how I remember this one is rational. If I say ration, ration sounds like fraction. Ration, fraction. So it's any number that can be turned into a fraction. So 4/5 is a fraction, as well as any number that can be turned into a fraction. So that would include something like 0.5. 0.5 can be changed into a fraction, even though it is not going to ask you in this lesson to tell me what that is as a fraction, but you need to be able to recognize that this is in the tenths place. So this decimal is 5/10, or 1/2, if you simplify it. So 0.5 can be written as a fraction. so it is rational. So 0.5. So any decimal can be written as a fraction as long as it's a repeating decimal. In other words, there's a certain digit or digits that keep going on and on and on. They keep repeating. So for example, like 0.6 repeating. Again, you don't need to know this right now, but that's the same thing as 2/3. And radicals can be written square roots. So just as a reminder what a square root is, a square root looks like this. And this is saying what number times itself is 4. And since the answer is 2, 2 can be written as a fraction. For example, 6/3 is 2. This is a fraction that equals the same value. These have the same value. These are both equal to 2. So I found two integers that if I write them as the quotient, that's what division is right here, if I can take two numbers and get the same value as that, therefore square root of 4 can be written as a fraction. So square root of 4 can be written as a fraction. Integers can, so for example, like 7, that is rational. I can write that as a fraction, like, let's say, 14/2. So every number can be written as a fraction unless it is irrational. And irrational is the opposite of rational. It means it cannot be written as a fraction. There's only two types of numbers that are considered irrational, and that is anything that has a pi symbol in the answer, so anything with pi, as well as anything that's in one of those square roots, those radicals that you can't find the square root of. So for example, square root of 3, that is irrational. There is no number times itself that is 3. There is no number, same number, like this one was 2 times 2 is 4. There is no number times itself that is 3, so this is irrational. There is no exact whole number times itself that is 4. If we enter this in a calculator, on this calculator there's the square root button right there, and on this particular calculator here, it's in yellow, the square root, so I have to click this yellow button when I click the square root button. So if I was doing square root of 4 on this calculator, I have to put the 4 first, and then I click the yellow button to take the square root of it. So it's 2. So if I do that for 3, the square root of 3, let's see what that looks like. It's irrational. This is exactly what irrational looks like. It's a decimal, it goes on and on and on, but I don't see anything that repeats. It goes on and on and on, just like pi. So if I, let's see, where's the pi button on this? Here we go. Pi. It goes on and on and on and on. There's nothing that repeats. This is what irrational looks like. So here's another example. Square root of 5. There is no number times itself that is 5. So if I take the square root of 5, let's see what that looks like. This is what irrational is. It goes on and on and on, nothing repeats. So this is saying that 2.2 times 2.2 is almost 5, but it won't work. 2.2 times 2.2 is about almost 5, but not 5. There is no number times itself that will be 5, so we have to estimate it like that. So that is what irrational is. So there's only two kinds of numbers that are irrational. Everything else is rational. It can be written as a fraction. Then the last word is real. Every single number in this class will be real. you'll start working with imaginary numbers. Now, we're not going to get into this in this class, but this is what an imaginary number looks like, or like that, until you get into your next math class. So right now, if I ask you if a number is real, you're going to say yes. And what real represents, or the term real means, it's a word to describe any number. So if I told you a formula works for all real numbers, you would know, oh, the formula works for any number. So any number, all of the above. Okay, so let's do a couple of examples here. Let's say we wanted to know 2. Let's talk about which of these words could apply to 2. So, natural. Natural means it is a counting number. 1, 2, 3, 4. So 2 is natural because it is a counting number. A little kid would count with 2. Whole numbers. 0, 1, 2, 3. Yep, 2 is a whole number. Integers. Integers are all the whole numbers, 0, 1, 2, 3, as well as opposites of it. So 2 is an integer. Rational. Ration sounds like fraction. You need to ask yourself, can this be changed into a fraction? And it can. Every number can, unless it's in the radical and it's irrational. There is no number times itself. Or if it has pi. This is neither of those. So this can be written as a fraction. For example, 4 over 2. 4 divided by 2 is 2. So it can be considered rational. These are opposites. You can't be both. Okay? It'd be like saying that, someone's wearing a blue shirt and then saying it's red. Okay? Can't. It's one or the other, let's say, if it's a solid shirt. So these are opposites here. And then real, all numbers are real. That's the term to describe all numbers. Okay, let's try 2/5. Natural. 1, 2, 3, 4. You will never say when you're counting 2/5. So it is not natural. Whole. 0, 1, 2, 3. We'll never say 2/5. So it is not a whole number. Integer. 0, 1, 2, 3. Also the negatives. So it is not an integer. Rational. Definitely is. Ration sounds like fraction. It's written as a fraction. Irrational. Can't be both, one or the other, and everything is real. Let's go ahead and try -4. And feel free again while you're watching these videos to pause and try the example for yourself and then push play and listen to the explanation, see if you're right. Natural, so it starts with 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You'll never say -4, so it is not a natural number. Whole, 0, 1, 2, 3, 4, 5, 6, etc. You will never say -4. Integer. Integer is 0, 1, 2, 3, 4, 5, 6, and their opposites, -1, -2, -3, -4. So it is an integer. Rational. Everything can be written as a fraction unless it has a pi symbol or a number in the square root that you can't, it doesn't have a perfect square inside. So this is rational. For example, -8 over 2. -8 divided by 2 is the same thing as -4. -4 can take on a rational form, so it is rational. Can't be both, and of course it's real. Let's try square root of 24. square root of 24, when we see something in the square root, we want to ask ourselves, what times itself is 24? 2 times 2, 3 times 3, 4 times 4, 5 times 5 is 25. So I'm seeing there is nothing that would work. So therefore, let's show it on a calculator so you can see what that looks like. Okay, this is irrational. If a kid was counting, or you were to count, they would never say this number here, so it's not natural. If they start at 0 and start counting, they will never say this number. Integer, that is not a whole number or its opposite. Rational, it cannot be written as a fraction because we don't know what place value the last digit is. It goes on and on and on and on, nothing repeats. So it is not rational. So it is irrational, and everything is real. Okay, let's look at point 4. Actually, let's do 0.43. So I kind of changed it up from what's in your notes here. I want to look at this one here. So, is it natural? If you start at 1 and start counting, is it natural that you will say this number? No. So it is not natural. If you start counting from 0, will you say this number here? No. Integer, if you start counting 0, 1, 2, 3, or their opposites, -1, -2, -3, you'll never say this number. Rational, can it be written as a fraction? This number is in the hundredths place. Whoops. It's in the hundredths place. So this number is read -43 hundredths. Therefore, this decimal has a fraction representation. So it is rational. Remember, everything can be written as a fraction unless it has pi or a number in the radical that we can't square root. It's not a perfect square. So it can't be both, and everything is real. And let's try one last example. Let's do square root of 16. Okay, when we see a square root, we have to ask ourselves, is that a perfect square inside? That means, is there a number times itself that is 16? Since 4 times 4 is 16, I know it equals 4. So, checking that on the calculator here, square root of 16, it is 4. So, this square root of 16 has a natural form. 1, 2, 3, 4. Whole number, 0, 1, 2, 3, 4. Integer, 4 is a whole number, so it is an integer. This square root of 16 has a rational form. For example, 12 over 3 is 4. So square root of 16 can change into a rational form that still equals 4. They have the same value. They're just written in different forms. So if it's rational, it can't be irrational. And of course, it's real.